MgAl-NOLDH, adsorption isotherms and multivariate optimization for CR-Vi removal. Welcome to Journal Club. The latest academic research, explained in plain English. Today we're looking at this paper from MDPI's Journal of Chemistry. It's authored by Cardinali, et al., from University of Genoa in Italy, and is published open access under a CC-BY license. Let's start by translating the title into more accessible language. When you read this title, you can understand it to mean in very simple terms that this paper is about a new material called MgAl-NOLDH that can be used to remove a harmful substance called CR-Vi from water, and it discusses how to find the best way to use this material. Let's expand on that a little. The research paper focuses on a material called MgAl-NOLDH and how it can be used to remove a harmful chemical called CR-Vi. They are testing how much CR-Vi the material can adsorb, stick to, at different concentrations, and using statistical techniques to find the best conditions for maximum adsorption. Now we understand the title, which is a good start, but before we can break down the full paper, we'll need to catch up on some terminology, jargon, background information and context. Specifically, there are some key concepts you'll need to be familiar with. Let's define them now. Adsorption. The process of binding molecules or particles to the surface of a material. Isotherms. A mathematical relationship between the concentration of a substance and the amount adsorbed onto a surface. Multivariate optimization, adjusting multiple variables simultaneously to find the best outcome. Anthropogenic, caused by human activity. Layered double hydroxides, a type of clay-like material with a layered structure and high adsorption capabilities. MgAl-LDH, a specific type of layered double hydroxide made from magnesium and aluminum. Anion exchanger, a material that can exchange negatively charged ions, anions, with other molecules in a solution. CR-Vi, a toxic form of the element chromium. Langmuir model, a mathematical model commonly used to describe adsorption on a surface. Inductively coupled plasma atomic emission spectroscopy, a technique used to analyze the chemical composition of a material. Now that we understand the title and key concepts, we're ready to dive in and break down this paper. In this presentation, we're going to attempt to answer 5 questions. 1. What were the researchers trying to figure out? Or more specifically, what was their hypothesis? 2. How did they conduct their experiment? That is, how did they test their hypothesis? 3. What were the results of the experiment? 4. What conclusions did the authors draw from those results? And lastly, 5. Why does this research matter? Why should you care? 1. What were the researchers trying to figure out? The researchers started with the hypothesis that a MgAl-LDH could be synthesized and used as an effective anion exchanger for the removal of CR-Vi from water through an adsorption process. 2. How did they conduct their experiment? The researchers used multiple techniques to synthesize and characterize the MgAl-nitrate LDH, including ICP-ICE, XOR-PD, FACE-M, and FTIOR. They also conducted adsorption tests to evaluate chromium removal efficiency and equilibrium adsorption of chromium, Vi, on the LDH. The experiments were performed using batch equilibration, rotary shaker, UV-vis spectrophotometry, and multiple linear regression with the additional package CAT. The experiments helped determine the minimum efficient contact time, equilibrium, and standardization of the recovering procedure. The adsorption process involves CrO4 plus MgAl-NO3 properties of MgAl-NOLDH B2NO3 plus MgAl-CrO4, where DHB denotes the double hydroxide bond. 3. What were the results? The researchers synthesized a compound called MgAl-LDH and characterized its structure and morphology. They then conducted adsorption tests to determine the compound's performance in removing CR-Vi from solutions, exploring the effects of different parameters such as LDH/solution volume ratio, pH, and CR-Vi concentration. They used a multivariate strategy called experimental design or DO and found that LDH mass/volume and solution chromium concentrations strongly influenced the percentage of adsorbed CRVI, while pH had limited effects. They developed a mathematical model that predicts the compound's adsorption capabilities within the whole experimental domain. They also tested the compound's behavior outside of the experimental domain, finding that the adsorption is almost complete in extremely acidic, neutral, and slightly basic pH conditions but decreases rapidly at pH values around 11 and above due to competition with hydroxyl anions in the solution. 4. What conclusions did the authors draw from their results? The MgAl-nitrate LDH compound was found to be effective in removing CRVI from aqueous solutions. The adsorption process was influenced by factors such as solution pH, initial concentration, and contact time. The optimum conditions for CRVI removal were achieved using a multivariate optimization approach. The experimental data fitted well with the Freundlich isotherm model, indicating that the adsorption process was favorable and heterogeneous. Overall, the study demonstrates the potential of MgAl-nitrate LDH as an efficient adsorbent material for the removal of CRVI from contaminated water sources. 5. Why does this research matter? The findings of this research could be useful in developing strategies for water treatment and remediation efforts, and could contribute to the overall goal of reducing pollution and improving water quality. We hope you've enjoyed this Journal Club presentation of MgAl-NOLDH, adsorption isotherms and multivariate optimization for CRVI removal. If you'd like to read the full paper yourself, which we encourage you to do, you can find it at DOI 10.3390/chemistry 50100045.